Hello, this is Mrs. Hyman. Simplify. -2 over 3 plus 5i. When we simplify with complex numbers, what we need to do is we need to eliminate this I in the denominator. So the way that we do that when we have a complex number is that we need to multiply by what's called its conjugate. And the conjugate of 3 plus 5i would be 3 minus 5i. And we need to multiply both the numerator and the denominator by this same value because in a sense that's just multiplying by 1, and so we don't change the value of our expression, we'll just simplify it. So we'll start first by rewriting. We have -2 over 3 plus 5i. And then we're going to multiply by 3 minus 5i in the numerator and 3 minus 5i in the denominator. Put parentheses here. Okay, so we just need to do some multiplication now and simplify. We have to take -2 times each term in our parentheses. So -2 times 3 will be -6. And -2 times -5i would make that positive 10i. And in the denominator, we need to use the distributive property, and we're going to take 3 times 3, which gives us 9, and then 3 times -5i would be -15i, and then distribute the 5i to each term. So 5i times 3 would be a positive 15i, and 5i times -5i is minus 25, and this time I squared, because I times I is I squared. So now we notice in the denominator we have a -15i and a positive 15i, and so that's going to cancel each other out. That equals 0. So now in our numerator we have -6 plus 10i, and in the denominator we have 9. This now is 0. We have minus 25i squared. Well, I squared is equal to -1. So we have really minus 25 times -1. So we can simplify a little further. We have -6 plus 10i in the numerator. 25 times -1 would be -25. So minus a -25, that means we're going to be adding. So we have 9 plus 25. So now we have -6 plus 10i. The denominator, 9 plus 25, is 34. And now we can simplify this fraction. We can just think of it as one big fraction that we can divide out the common factor of 2. So we're going to divide each term by 2. So we'll simplify this one last step. -3 divided by, let me try that again, -6 divided by 2 is going to give us -3. And 10 divided by 2 is going to give us 5i. And the denominator also being divided by 2 is 17. And that can be separated, come down just a little bit, to -3 over 17 plus 5i over 17. Our second problem, 6 minus 7i over 3i. Well, again, we need to eliminate the I that is in the denominator, but this time we have a monomial, so we are going to multiply the denominator and the numerator both just by I, because if we remember from the first problem, when we multiply I times I and get I squared, that turns into a negative 1. And so that will help us to get rid of that I in the denominator. So we'll start with our problem, 6 minus 7I over 3I. And we're going to multiply both numerator and denominator by I. And we'll put parentheses here so we remember to distribute. Okay, now we're going to distribute the I. So we'll have 6 times I, which gives us 6I. And then we distribute negative 7I times I is going to be negative 7I squared. And now the denominator, 3I times I is 3I squared. So now again we'll remember that I squared is equal to negative 1, and we have that in two different places here. So we have 6I minus 7 times negative 1, and in the denominator 3 times negative 1. So we'll simplify a little bit further now. We have 6I, and this will become plus 7 all over negative 3. So now we need to do a little more simplifying and put this into standard form. So let's separate it apart first. And we're going to put the real part first, which is that part without the I in it. So that's going to be the 7 over negative 3. And then the imaginary part, that will be the 6I over negative 3. And we can simplify this fraction here. So now we have negative 7 over 3. And then 6 divided by negative 3 is negative 2I.